Hello and welcome to this lecture of machinery fault diagnosis and signal processing. Today's topic is frequency domain analysis. We have seen there are various signal processing techniques by which we can analyze an acoustic signal or a vibration signal to detect the various faults in the machinery, such as time domain analysis, frequency domain analysis, time frequency analysis, order analysis, envelope analysis, etc. In the last lecture, we have seen the time domain analysis in very detail, and there we have seen that the time domain statistical parameters actually help in drawing a meaningful conclusion out of the signal in time domain. So there we have seen the limitations of time domain analysis. The basic limitations of time domain analysis is that the values of time domain statistical parameters are inconsistent with the increase in the size of the defects or with the increase in the RPM. Okay, sometimes the time domain statistical parameters shows upward swing with increase in the defect diameter. At the same time, further increase in the defect diameter, uh, the statistical parameters start reducing. So these are some of the inconsistent results that we obtained from time domain statistical parameters. So only time domain statistical parameters may not be sufficient to draw a meaningful conclusion. It is time domain analysis has to be combined with frequency domain analysis so that the strong conclusion, a concrete conclusion can be drawn from the analysis. So it is always recommended that do not rely on the results of time domain analysis. Time domain analysis has to be associated with frequency domain analysis, and the results of these two analysis would make your conclusion more concrete. The other limitation of time domain analysis is that it doesn't it only gives, it only indicates the presence of fault in the machine, presence of fault in the signal, but it doesn't give the exact location of the fault. So this is another big limitation of time domain analysis. So it only gives the presence of fault. So it is similar. I will give an example. If you are having some abnormality in your body and you go to your doctor, and doctor only suggests that something is wrong, but where something is wrong, what is the location of that particular problem in the body, he doesn't give. So to find out the exact cause of the problem, the doctor would suggest a number of tests, and from the analysis of those tests, the doctor come to a conclusion that the fault lies in so and so part. In the same way, the time domain analysis only gives or only indicates the presence of fault in the machine, but it doesn't give the exact location of the machine. So based on these limitations, uh, today's topic of discussion is frequency domain analysis. All the drawbacks or limitations of the time domain analysis can be rectified by using a frequency domain analysis. So frequency domain analysis is capable of giving the it not only gives the indication of presence of fault, but also gives the indication of the location of the fault also. So this is the big advantage of frequency domain analysis, and for that we need to transform the signal from time domain to frequency domain. Now what is this time domain to frequency domain conversion, and how a signal is converted from time domain to frequency domain? So what is time domain analysis? In time domain analysis, a signal is represented in time versus amplitude graph. In frequency domain analysis, the signal is represented in frequency versus amplitude graph. Now here on the left side, you can see a signal in time domain. Now there are two types of signals. One is indicated by a blue signal, a blue wave, and another signal is indicated by a red wave. Now the amplitude of the blue wave is higher than that of the red wave, but the distance between two successive peaks is quite large in case of blue wave, whereas in the red wave the distance between the two successive peaks is less. So frequency is nothing but reciprocal of time period between two successive peaks. So that is why the amplitude of the blue wave is represented in a frequency domain with a much higher peak, whereas uh, the frequency of the red wave is quite high, because the time period between the two successive peak is very less, and that is why the frequency of this red wave is high, and that is why a small arrow whose frequency is much higher than this large arrow. So this large arrow indicates the frequency of a blue wave, and the small arrow indicates the frequency of the red wave. This time domain analysis is just okay, I will explain in the next slide. So here a three-dimensional figure is given. So on the x-axis the unit is time, on the y-axis the unit is amplitude, on the z-axis the unit is frequency. So there are three types of waves, or three types of time domain waves. You can see a blue one, a green one, and a brown one. Now you can see that the distance between the two successive peaks for blue one is quite high. The distance between the two successive peaks of a green one is further less, and that of a brown wave is very less. That means this blue wave belongs to a low frequency wave. The green wave indicates the medium frequency, and this brown wave indicates a very high frequency. So if you see these waves from the left side, then you can see the amplitude versus frequency graph, and that is nothing but a frequency domain plot. Okay. So if you see this picture from front side, then it is a time domain analysis or time domain representation, which is time versus amplitude. But if you see this picture from left side, then you can see the graph of frequency versus amplitude, and that is the frequency domain plot. Okay. So I hope that you have understood the frequency, time frequency plot, and frequency plot. Now how to convert it? So we have already seen that the higher frequency, how a signal looks in time domain as well as frequency domain, and to convert the signal from time domain to frequency domain we require spectral analyzer. So by using a spectral analyzer we can convert the signal from time domain to frequency domain. The study of frequency domain is important to find out the exact location of the fault. Without converting a signal from time domain to frequency domain, or without analyzing a signal in frequency domain, you actually cannot find the exact location of the fault. Now who will convert the signal from time domain to frequency domain? So fast Fourier transform, it is also called as FFT, fast Fourier transform. This fast Fourier transform algorithm helps in converting a signal from time domain to frequency domain. So the time domain vibration signal is typically processed into frequency domain by application of Fourier transform, usually in the form of fast Fourier transform algorithm. So this FFT algorithm converts the signal from time domain to frequency domain. But how this algorithm works? The principal advantage of the method is that the repetitive nature of the vibration signal is clearly displaced as a peaks in the frequency spectrum. So uh, the frequencies which are repeated at a higher level, then these such frequencies get accumulated, and the frequencies which are non-repetitive, they get diminished off, and the repetitive frequency can be seen as a prominent peak in the frequency domain. So this is how this fast Fourier transform works, and this is the formula for fast Fourier transform. So in this frequency domain analysis, we have seen that the advantage of frequency domain analysis, that it will give the location of the fault, and you can actually find out the exact location, and you can do the remedial action on the machine. Okay. Now we will further see this frequency domain analysis in very detail in the coming lectures. Okay. So thank you very much.